We are going to be talking about graphs of sine and cosine functions today. And then in the next class, we're going to move on from sine and cosine to, all the other four, okay? So, tangent, cotangent, secant, cosecant. Okay, so take a look here. For sine and cosine, right? What is extremely important, and again, this shouldn't be new if because we've covered it in algebra 2. So, thank you. So the domain of sine and cosine functions for both of them is negative to positive infinity, right? That means it is never undefined. There are no holes in the graph. There are no vertical asymptotes. That's it. Now, the range for sine and cosine functions goes from -1 to 1, okay? And we know this because when we're on the unit circle, right, here the coordinates are 1, 0. Here the coordinates are 0, 1, -1, 0, 0, -1. So if I'm just looking at the sine values, are those the x or the y coordinates? The y coordinates. So here y is 0, then y is 1, then y is 0, y is -1, y is 0. So y just oscillates, right, between -1 and 1. So that's the range of sine. And it's the same for cosine. It just goes, right, the x values go from -1 to 1. So same for cosine. Okay, now let's take a look here. This is what the graph of a sine function looks like, right? So what are some important things that we have to look at here? First and foremost, when the angle starts, so here the angle is 0 degrees, right, or 0 radian. At 0, the sine starts on the axis of oscillation, so the y value is 0, okay? And then when we go, this is one cycle, and it ends at 0 again, okay? In this, the time it takes for it to go through one cycle, the angle goes through 2 pi, right? So the angle starts at 0, pi, 2 pi, right? So that's one period of a sine function. The time it takes, how long it takes to complete one cycle is 2 pi. Now, what else we need to know here is this. Sine is 0 here, here, here. And then it goes to the maximum and it goes to the minimum. How many total points is that? 5. 5 critical points is what we call them. Okay? Now, let's go to cosine. When the angle is 0, cosine does not start on leaf.
I'm not doing anything.
When the angle is 0, cosine does not start on the axis of oscillation. It starts away from the axis of oscillation. So we have a maximum, 0, minimum, 0, maximum. Again, 5 points. And those 5 points are either 0 or minimum or maximum. That's it. Okay? All right. What else? So take a look at the cosine and the sine, right? Right here. Do you see how if this was a movable graph, and if I just grabbed this curve and I just shifted it over, it would look like the cosine, right? That's because, sine and cosine are related like that. They're just half a pi away from each other, all right? So both of these, because they're like derivations of the same thing, they're called sinusoidal graphs, right? That's here, okay? So these are called sinusoids or sinusoid, like deriving from the sine, okay? What else do I want to say? There's so much I want to say. I could keep talking about this forever. Okay, let's move on, and then we'll talk about even and odd functions. Okay, so we talked about the fact that the period is 2 pi, okay? So here's what a general equation for sine and cosine looks like, right? You've got factors of a, b, c, and d. each and every one of those constants have a purpose in the equation. So today we're going to talk about those. Okay, first of all, A, this factor A is the amplitude is what we call it. So if the absolute value is greater than 1, it's an expansion. If the absolute value of A is less than 1, it's a compression. In the world of trig, it's also called amplitude. So what is amplitude? If I take a sine graph and split it halfway horizontally like this, the distance between that axis of oscillation, that middle line, and the maximum, that's amplitude. It's the same as this distance here. Always absolute value. Okay, so let's take a look here. So we have sine of x and g of x. So you see how they're pretty much the same, except there is a change in amplitude here, right? Amplitude of f is 1, amplitude of g is 3. Okay, so amplitude of g is 3. So what I'm going to do here is I'm usually going to give you a grid like this, like on a test or a quiz, and I'm going to have you put the x-axis. Okay? This is the x-axis. That's where your angles are going to go. So here, we're going to start at 0 radian. And then I'm going to go 4 units over. Now, it's up to you whether you want to skip spaces or not. I am, just because I want to spread it out a little. So I'm going to go from 0 to 2 pi. That's my period. Halfway is pi. Pi over 2. 3 pi over 2, right? These are the special angles, like the quadrantal angles. Okay, now, I'm going to leave the y-axis for later. All right, so what I'm going to do first here is I'm going to graph sine of x, right? The amplitude for sine is 1. Because it's a sine, it starts on the axis of oscillation. Then at the next critical point, it goes up 1, back to the x-axis, down 1, and here. Okay, so that's how f of x looks. Okay, so now here, because that's the 0, I am going to go ahead and put the y-axis. Okay, so this now is f of x. Okay, on the same axes, I'm also going to graph g of x. G of x is the same, except it's got an amplitude of 3. Because it's a sine, it still starts here. But now the maximum is just 3 units up. Here. 1, 2, 3. Back to 0. 1, 2, 3. Here. And that's how it looks. Okay, and here we just want to calibrate. Okay. Do you see how they're the same? Except the amplitude is just higher or lower. That's all. The location of the maximum and the minimum are the same. The location of the zeros are the same. So if you're musically inclined and you're playing, let's say, G, right? This is the same G and this is the same G. It's just the blue is, a higher volume. It's like more decibels. That's it. Okay? All right. So let's go ahead and do this one. Now here, I have a cosine, but here I have a -2. So what's the amplitude of g of x? Just 2, because amplitude is always positive. What's the negative do then? It's what's the word? Reflection around the x-axis. Good. So here we're going to put, and I'm just going to graph g of x. I'm not going to graph both. So this is 0, 1, 2, 3, 4, 2 pi, pi, pi over 2, 3 pi over 2. Here is 0, the y-axis. Okay, so this is a cosine. It starts away from the x-axis. So is it going to start at the maximum or the minimum? Minimum because it's -2. So here it's -2 starts there, back to 0, then to the maximum of 2, 0, here. And then, okay, so look, this is not a V. You got to make it look like a cosine. So make it look like that curve, okay? Because remember, this is part of a wave, so it's got to look like a wave. All right, we're good? Okay. The only points ever are minimum, maximum, or 0. It can't go anywhere else, okay? All right. What about period? So period is how long it takes for one cycle to complete, okay? Because for the default, it's 2 pi. When we modify the period, it's always a fraction of the 2 pi. So to find the period of a sine or cosine function, it's always 2 pi over absolute value of b, okay? So what we also do when the period is modified, you take the term bx plus c and you solve it you put it into this inequality and you're going to solve that inequality. So let's do one here. So take a look here. I have a cosine and a cosine half x. So what's the difference here? What has changed? The period has changed, right? It's got a half in front, so the period has changed. So amplitude of g of x is what? 1. Now, the period is 2 pi over a half, which is 4 pi. So now it's going to take 4 pi for the period to complete. So this is a slower wave. Okay, so how are we going to graph this? What I want you to do is we go from 0 to 2 pi always, because this is the default period. Inside, you put this term, half x. And now you solve for x. So you multiply by 2 everywhere. You're going to get 0, x, 4 pi. Okay, so what this is now, this is the beginning and the end of the graphing region. Okay, or of the new period. Okay, so here's what we're going to do. X-axis, we're going to go from 0 to 4 pi. Okay, 2 pi, pi, 3 pi. Everybody knows what I'm doing over there? Like midpoint, midpoint, midpoint. Okay, so now, what are we graphing? Cosine. So we're going to start away from the x-axis. Do I start at the minimum or the maximum? Maximum. I start from here, go here, go down, and so on. Oops. So now, oh, why can't I? Okay? So if you were, again, playing music, right? So this would be maybe like a note like at a lower octave, right? So it's like huh? Yeah. I mean, like it depends, right? So if you're playing like, you know, a C, this is like one octave lower or something, right? It's just like a lower note. Okay. Frequency and period are related. Here is the thing with frequency. If you were standing on top of this wave, looking down, right, and let's say there was like a glass floor, and like the waves are passing under you. If you took a timer, right, a stopwatch, and you're like, okay, let me see in 1 second how many waves are gonna pass by me. That's frequency. Okay, so if you have a wave that looks like this, right? In 1 second, you'll have, however many waves pass by you. But if you have a wave that looks like this, in 1 second, you're going to have more waves passing by you, right? So that's frequency, okay? If you think of, let's say, radio waves are waves that look like this. If you think of, X-rays or gamma rays, they look like that, right? So they have like a different frequency. And radio is because they're such a slower curve, they're very harmless, but that, higher frequency, gamma rays can kill you, right? Okay. So let's just get used to some terminology here. So a bass tuba, you guys know what a bass tuba is? It's very low, right? Okay, so it can hit a note with a frequency of 50 cycles per second or 50 hertz. So this is just the frequency. Oh, I forgot to tell you guys what frequency is. So frequency is the reciprocal of the period. So if period was 2 pi over b, frequency is the reciprocal, b over 2 pi. Okay? All right. So this has a frequency of 50 hertz. It has an amplitude of 0.75. Write an equation of a cosine function that can be used to model the initial behavior of the sound wave associated with the note. Okay, so let's write a cosine function. What's a cosine function look like? This, a cosine bx plus c plus d. Okay, so what are we given here? A is 0.75. Here I'm given frequency. Frequency is 50 hertz. Okay, frequency is 50. Now, what was the formula for frequency? B over 2 pi. So B over 2 pi is 50. Okay? Because, there is no frequency here, but there is a B. I use the frequency to extract the B. So B is multiplied by 2 pi, 100 pi. And that's all the information I have. I don't have any information given about a C or a D. So Y is going to be A, 0.75, cosine 100 pi x. That's all. Right? It's just getting used to like terminology. Okay. Yep. Okay, now phase shift. Any questions?
Wait, so you need to answer like that?
Yep. Okay.
Wait,
Yep.
hold on. So is frequency the same as?
Frequency is the reciprocal. Period is 2 pi over b.
Yeah.
Frequency is b over 2 pi.
But if you graph this out, it would be like the phase, and then it'd be 100.
Right. So we use the frequency to figure out b because both frequency and period are related to the b. One is this over 2 pi, the other one is 2 pi over this.
If 2 pi is 100 pi, then wouldn't it be like really slow?
Yeah. Right, that's fine. Like we don't care how fast or slow it is. We're just like writing the function. It is a,
Trying to figure out
yeah.
like, how to graph it.
Yeah, the period will be 2 pi over 100. 2 pi over 100 pi. Okay?
Oh.
Yeah. So it'll be 1 over 50. Because the frequency is 50, the period is 1 over 50. Okay. Phase shift is what we know as a horizontal translation. Okay? So it's a horizontal translation, but in the world of trig, we call it phase shift. So we talked about what A does. We talked about what B does. B and C together give us the phase shift. Okay? Now, phase shift is this. negative C over B. But you know what? I hate giving people more things to memorize. So please, we're not going to memorize that, okay? What we're going to do instead is solve for x. So you take the bx plus c, set it equal to 0, and you solve for x, and that gives you the phase shift. Because that process is very similar to what we used to do in like horizontal translations, right? So like if I had, you know, f of x is equal to x plus 2 squared. Remember for quadratic form, like, I mean for the parabola, where does this move on the x-axis? Left or right? Negative 2, right? How do you do that? X plus 2 equal to 0, x equals negative 2. We're just going to do the same thing here. So if I have a function like this, look at how beautiful that function is. Y equals sine x 5x, right? Sine of 5x plus pi over 4. What's the amplitude there? 2. Okay. What's the period? 2 pi over what number? What's b? 5. Okay, that's b. So that's 2 pi over 5. You don't ever have to write 2 pi over b, just write 2 pi over 5. What's the frequency then? Yeah, 5 over 2 pi, just flip it. It's the reciprocal. Phase shift. You know how we always took the stuff in the parenthesis and set it equal to 0? That's what we're going to do. Just take the stuff inside the parenthesis, 5x plus pi over 4, set it equal to 0. 5x is negative pi over 4. And then divide by 5, which is like multiplying by 1 over 5. So x is negative pi over 20. So did this function move to the left or right? Left, how much? Pi over 20 to the left. Yep, okay, good. So now we're not going to start at 0 then, because we've moved. So instead now we have to figure out where we're going to start. So what we're going to do is the following. We're graphing a sine. The default period is from 0 to 2 pi. Inside of this, I put this, 5x plus pi over 4. Okay? And now I'm going to solve this one for x. So here's what I'm going to do. Subtract pi over 4. So we get negative pi over 4. 5x, 7 pi over 4. Awesome. Divide by 5, which is the same as multiplying by 1 over 5. Okay, negative pi over 20. X, 7 pi over 20. This tells you where the cycle starts, where the cycle ends. Does it make sense that it starts at negative pi over 20? Yeah, because that's what the phase shift was. Okay, so now look at what we're going to do. Here, okay, I'm going to put negative pi over 20, 1, 2, 3, 4 pi over 20. Okay. Now I got to find midpoints. This is like more math to figure out the 5 points than to actually graph this complicated function. Oh, 7 pi over 20. Thank you. Oh my gosh. Yep. Okay. So here's the first midpoint we're going to find. So orient yourself. This is halfway between these 2 points. Back in geometry, how do you find midpoint? Add them and divide by 2. So that's going to be half of, that's the dividing by 2, negative pi over 20 plus 7 pi over 20. Okay, so add, divide by 2. So this is equal to half of 6 pi over 20, which is 3 pi over 20. Okay, Now I'm going to take this. What is that the middle of? The black and the red. So I'm going to do the same thing over there, right? So half of negative pi over 20 plus 3 pi over 20. Right, this will be 2 pi over 20, and then the half pi over 20. What's the green half of? It's half of this and this. So
10 pi over 20 divided by
10 pi over 20 divided by 2, 5 pi over 20. Okay, is this the only way to do this? No. If, you know, look, some people like look at this and they're like, that's what it is. Okay, awesome. I'm not like that, okay? Like, don't pressure me. I need a little time to figure things out, so I write stuff down, okay? And that's okay. You know, and then once I get here, I'll be like, okay, 1 pi over 20, 3 pi over 20. Oh, okay, that's a pattern, so it needs to be 5 pi over 20, 7 pi over 20. Doesn't matter. Write down the work. Just, you know, look at it. And I don't just do it right. Okay? That's up to you. Okay, let me put the y-axis and I'll take your question. So where is 0 here? Smack in the middle of these two, right? So that's where the y-axis goes. But you know what? I'm going to put it later because I don't want it to confuse me. Because look at what I'm going to do now. What am I graphing here? Sine or cosine? We forgot. It's been so long. Sine. Sine starts here. What's the amplitude? 2. I go up to 0, down to 0, graph a cute little sine. And I find when I draw the y-axis after I do this, it's less confusing for me. Yes. Okay, wait, Todd had a question first.
Do you simplify the x values? Because 5 pi over 20, do you simplify that?
Oh, yeah. It should be pi over 4. Thank you. Yeah, Yali?
Wait, so for sine, you start on the
Axis of oscillation. Waiting.
wait, so cosine you start at on the y-axis?
Cosine, you start away from the x-axis. Sorry. Cosine, you start away from the axis of oscillation. You either start at the maximum or the minimum. So I refrain from saying on the y-axis because if there is a phase shift, you don't start on the y-axis. So it's more correct to say you start away from the axis of oscillation. You either start at the maximum or the minimum.
Wait, axis of oscillation is like where the graph starts?
Axis of oscillation is the thing that is oscillating around. So it's the line smack in the middle. So this is oscillating around the x-axis. That's the
But if
axis
it
of
was to
oscillation.
say like -2 sine, then the oscillation would be -2.
Okay, so if it was -2 sine from here, you would go down to -2. It would go this way.
So what determines the
Phase shift,
the oscillation?
What do you mean?
Where in the function does it determine like what the axis of oscillation? Like you know how
The default is always the x-axis, and then we're gonna see now if there is a shift. So hang on. Yeah, did you have a question? Oh, I thought somebody else was raising their hand. Okay, let's do the next one. Oh my gosh, look at this one. Okay, what's the amplitude here? 1/2. What's the period? 2 pi. What's the frequency? Okay, listen up, people. I don't know why students have this belief that pi can never be in the denominator, right? So when I ask for frequency, they're like 1/2, and they're like, wait, can I put pi in the denominator? I don't know. And then they're not sure, and then they think they're all like, like smart and stuff. They're like, oh, I'll just fool her. And they just put like the pi somewhere here, so it's like, kind of in both places, like depending on, no. Be bold. Because if I see it like this is not full credit, because I don't know where that pi belongs. So be bold. Say pi belongs in the denominator, right? Or in the numerator, right? Just make a decision, guys. Make a decision. Okay. It really bothers me when that pi is like ambiguously just floating around the fraction over there. Okay. I mean, Okay, phase shift. What's the phase shift? Negative pi. X equals negative. So how did we know that? X plus pi equal to 0. X equals negative pi. Okay. So to graph, we're going to go from 0 to 2 pi. Always 0 to 2 pi for sine and cosine. X plus pi goes in here. Minus pi, minus pi, minus pi. So I get negative pi, x, pi. So here, I'm going to go from negative pi. Okay, you know what? From negative pi to pi. This time I'm going to be a rebel. I'm not going to skip the boxes just to show you that you can do that. It's choice. I'm going to go this way. Okay? Halfway is 0. Negative pi over 2, pi over 2. Okay. What else do I have here? What's this business about? Yes. That's your vertical shift. We got a vertical shift over here. Plus 1. So everything shifts up 1. That means my new axis of oscillation is at y equals 1. Okay? So now, what am I graphing? Sine or cosine? Okay, does sine start on the axis or away from the axis? On the axis. So here's my first point, negative pi. On the axis means my first point goes on the axis. Then, am I going to go up or down? Up half a unit, 0, down half a unit, 0, and look at that cute little sine graph over there. Okay? Next, I'm going to put up, how come you guys aren't as excited about that sine graph as I am? I'm going to put the y-axis. But now I need to calibrate this. So this is 1, 2, and so on. Fabulous. Doesn't that sound great? Say yes. Okay. Awesome. All right. Just a cute little sine graph. All right. It's the period, right? Because it's the same. Yeah. Okay. So, okay. One other thing. What is the period here in this problem? 2 pi. So now look. It starts at negative pi and it goes to positive pi. How much distance is there from negative pi to positive pi? 2 pi. Do you see where it comes in? Look at this one here. It's like black magic, right? We started at negative pi over 20. We went all the way to 7 pi over 20. How much distance is there from negative pi over 20 to 7 pi over 20? The way we find that is you subtract, right? You do 7 pi over 20 minus negative pi over 20. That's 8 pi over 20, which is how much? Two pi over 5. That's the distance from here to there. What did we get for the period? 2 pi over 5. It's like black magic. Yes? Okay. One day you'll learn to appreciate that more than you do now. When it sinks in, you'll learn to appreciate that, but it's really cool. Okay, now let's go backwards, because why not? What if I give you the graph and you have to write the equation for me?
Then
We can do that. Okay, let's do it. That's a good question. First thing you want to do is split it down the middle. Draw the axis of oscillation. Okay, so really, it can be both. Okay, right. But we're going to agree, for our purposes, I'm not going to give you ones with a phase shift. So let's just look at, when the angle is 0. Does it start on the axis of oscillation or away? If it starts on, then it's a sine, okay? I mean, it's not a sign from God, like it's a sign, right? Okay. So what's the amplitude here? 4. It's just this distance. Okay, period. So we need A, B, C, D. I just told you there is no phase shift, so C is going to be 0. But now we need B. For B, we need the period. This thing starts here. Let me get another color. This thing starts here, and here's where a cycle ends. So the period is 4 pi. Okay? So period is 4 pi. 4 pi is 2 pi over b, right? That's the period. So now we need to solve this for b. So 4 pi times b is equal to 2 pi. B is 1/2. Okay. I said we're not going to have phase shift, so there is no C. Now, D. This has a shift downwards of 2, so D is equal to -2. Okay, so now, Y is A sine BX plus C plus D. There's no C, so let's fill in what we got. 4 sine half x minus 2. Good? Okay. Okay, now, what if you have this situation? So if you've got a graph, then you know exactly if there is a reflection or not, like if it goes, if it's positive or negative for the A. But what if you don't? What if you've just got these? Okay, we've kind of been ignoring one thing, is that in all of our formulas, like for period, it's 2 pi over absolute value of b. But I've kind of been ignoring that because you can for until now. So here we're going to write a sinusoidal function, either sine or cosine, with a given period and amplitude that passes through the given point. So the period is 4 pi, the amplitude is 2. So I know that A is 2. Now, the period is 4 pi, correct? So 2 pi over absolute value B is 4 pi. Okay? Now, when you solve for B, you get a half. That means B can either be -1/2 or it could be a +1/2. Okay? Sorry. Oh, okay. So how do you know? You kind of just have to check. Okay. Okay, so now we have a point here. That's your x and y. All right, so how would this look? Let's write up a function here. Okay, I'm just going to try this out. Okay, when you put in your amplitude, and your 1/2, that's how it looks. Now check to see if when you put in your x and y, it works in here. Okay, so what's y and what's x? X is pi and y is 2. Let's check. Is 2 equal to 2 sine half a pi? Is it? What do you think? What's this? 2 sine pi over 2. What is sine of pi over 2? Sine of pi over 2? 1. 2 times 1, is that equal to 2? It is equal to 2, so that is the right function. Okay? If not, you might have had to switch to -1/2. Right? If it was the other option. Yeah.
Wait, how do you know if it's sine or cosine?
So that too you can check, right? You can put in like the value. So if you did a cosine over here, Cosine of half of pi would give you what? 0, so that wouldn't work.
So like, well, you just knew that, but you would have to check.
Yeah.
It.
Yeah.
I didn't get it.
Okay, so you have to